we talk about nonwovens, what are the advantages of nonwovens? And based on the slide I showed previously with the spring action, nonwovens provide a controlled cut with minimal stock removal. They produce a very predictable, consistent, uniform finish from the beginning of their life to the end of their life. They minimize or eliminate smearing or discoloration of the workpiece. They can allow for the automation of operations that'll increase production and time saved. Nonwovens are not only used manually, mechanically, but they're also used in robotic applications. So what are those advancements? There are new nonwoven backings that have improved durability, improved flexibility. They allow for better bond and grain adhesion. There are new chemistries, resin chemistries that eliminate smearing. They reduce shedding and chunking of the product. And from an abrasive standpoint, new technologies in abrasives provide higher cut rates as well as more consistent finishes. And some of the pictures I'll show you as we move on here will explain that in a little more detail. One of the things combining these new technologies together in new nonwoven products is they can reduce or eliminate steps. They can produce up to 8 times more work and get the job done in less time than our traditional conventional nonwoven products that we've been producing. And they can deliver more consistent finishes. So when we combine resin chemistry, we combine the new backings, we combine the premium abrasives, what can it do? It can and it does eliminate steps. So the picture on the top, on the left, is a unified blending wheel. And that product, which is blue in this picture, has agglomerated abrasive. It has smear-free resin chemistry. And what that combination allows us to do is eliminate what were 3 different steps of a flat disc, a fiber disc, and a surface conditioning disc that used to be used in sequence. This type of product now on this particular example here in a right angle grinding and finishing application, the Vortex agglomerated blending product can do all 3 steps in one. It's also capable of doing light stock removal, blending and finishing in one step, where you might have used 2 or 3 different grit sizes to get that application completed. If you look at conventional surface conditioning materials, they can only grind on the face of the disc. So in this particular scenario, that surface conditioning disc on the left can only work on that where the abrasive grain is coated. It can't work here, so you can't use the back of the disc, and it can't work on the edge. So with traditional surface conditioning products, you can only grind on the face of the disc. When you start using unified products and products that can grind in 3D, you have a product that can virtually work that entire surface of the part in one motion or one action. So even ergonomically, from an operator standpoint, they only have to hold the tool one way, and they can grind and finish, deburr, and blend that part in one motion versus having to reverse the tool and move it upside down. When we look at the impact on total costs by using these new technologies, I'm going to use an example here with our surface conditioning products. And the reason I have this bar chart is just want to show the real drivers in metal fabrication are not the consumable abrasives. It's really labor and time. The time and labor savings is really the factor here, and where using premium or latest abrasive technologies in nonwovens is the value to the metal fabricator.